about 7.3. Notice that we've got a lot of formulas that you have to know. You actually don't have to know all the formulas in that section, but you do need to know the double angle formulas and the half angle formulas. So you don't have to know product to sum, sum to product, or the lowering powers formula, but the other two groups you do, double angle and half angle formulas. So we're just going to go ahead and work some of these problems. 7.3, number 4, is the tangent of x equals negative 4 over 3, and it tells me that x is in quadrant 2, and the directions for this particular problem are to find the sine of 2x, the cosine of 2x, and the tangent of 2x. Alright, so I'm looking for my double angles here. Alright, and remember that the sine of 2x is 2 times the sine of x times the cosine of x. The cosine of 2x is, I've got 3 different choices here, and so we're going to use this one primarily, but just understand that I could write cosine in terms of sine. I could substitute in my Pythagorean identity and rewrite this in terms of sine, or I could substitute in my cosine. Remember that the sine squared would be cosine squared of x minus 1. I could substitute that in as well and write everything in terms of cosine. Alright, and then we'll talk about tangent in just a minute. So, also notice that if I am trying to find the double angle of these trig functions, that I need to know the sine of x and the cosine of x. So that's the first thing I'm going to find. I want to find the sine of x and what the cosine of x equals. Now, if I'm going to find these, I'm just going to use this ratio right here and make sure I pay attention to what quadrant my angle's coming out of. But remember that in quadrant 2, and you certainly don't have to draw this in quadrant 2, just draw your triangle and remember what your sines are coming out of that quadrant. So in this particular case, I've got opposite over adjacent, right? And this would be my negative 3, or just understand that tangent is negative in quadrant 2. So this means this is a 3, 4, 5 triangle, and that means that the cosine of x, well, let's do the sine of x first. The sine of x is opposite over hypotenuse, and it's in quadrant 2. And even if you think about that, I'm going over and up. Okay, so this is going to be positive because sine is positive in quadrant 2. And then the cosine is going to be adjacent over hypotenuse, and in quadrant 2 cosine is negative. So there, I've got enough information now to where I can just plug these in my formulas and figure out what my double angles are. So the sine of 2x, well, that equals 2 times the sine of x, which I already found to be 4 over 5, times the cosine of x, which I found to be negative 3 over 5, and then just multiplying straight across, numerator, 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 times denominator, denominator. I get negative 24 over 25. Alright, so there's my answer for that. The cosine of 2x is going to equal cosine squared, so I've got negative 3 over 5 squared minus sine squared, which is 4 over 5 squared. Alright, so I just do the arithmetic here, and I've got 9 over 25 minus 16 over 25, which is negative 7 over 25. Okay, and then the last one they're asking for is the double angle of tangent. Now, I've got a formula over here that I could find the tangent of x. I actually gave that to me, and I could just plug it in and go with it if you want to. I'm actually just going to use the fact that I know that the tangent is sine over the cosine. And since I've already found both of those values, I'm just going to plug them in. So I've got negative 24 over 25 over negative 7 over 25. And if you flip and multiply that, A negative divided by a negative, there's a negative right there. That is positive 24/7. Okay, and like I said, I could have plugged this in. Actually, let's plug it in just to show you. So if I had plugged it in my formula, I would have had 2 times the tangent of x, which is negative 4/3, all over 1 minus negative 4/3 squared. Alright, so when I multiply that up top, I get negative 8/3. On the bottom, I get 1 minus, and then I've got 16/9. Alright, I need a common denominator there, so that's 9/9. And so that's going to be negative 7/9. Alright, and when we flip that and multiply it, we've got negative 8/3 times negative 9/7. And I can cross cancel and multiply negative times negative, and I get 24/7. So either way I go. Since you're doing all the work to find sine and cosine, I would just use the fact that I know that tangent is sine over cosine and go with it there. Alright, let's keep going. Alright, 22 asks for the exact value. Alright, so this isn't one that you can just plug in your calculator and give me what the decimals are. That's not, a decimal approximation is not an exact value. So if I'm looking at this, I certainly could look at my formulas and think, alright, what do I need to know here? Well, if I double this right here, instead of a decimal, instead of 112.5 degrees, if I double that, I'm really looking at the cosine of 225 degrees divided in half. Alright, that's the same thing. 225 divided by 2 is 112.5 degrees. Alright, so if I'm looking over there, notice that this is a half angle formula. My half angle formula, those are all right here, and notice that the quadrant of the angle over 2, the half angle, determines the sine. So if I'm looking at this, I'm looking at that and going 112 or 225 divided by 2. What quadrant is that in? Well, that's in quadrant 2. This is going to be in quadrant 2, and cosine in quadrant 2 is negative. So when I look up here and go, I've got to use the cosine, the half angle of cosine, and I'm trying to figure out if I'm going to use the positive or the negative value. That is determined by that half angle. So this is in quadrant 2. Cosine is negative in quadrant 2, so I'm going to use the negative value of all this. Now, let's just plug it in. So we've got the cosine of that is going to equal, let me write it again. Cosine of 225 divided by 2 is going to equal the negative, we've already established that, square root of 1 plus the cosine of 225 degrees. That's just my x. That's not my x divided by 2. Right? This is after I doubled it. And then all that's over 2. Alright, so let's clean this up. I've got negative, and then I've got 1 plus, alright, so let's kind of do this off to the side. If I were looking for the exact value of cosine of 225 degrees, remember the steps you go through to find the exact value. I'm thinking, what quadrant is this in? Well, this is in quadrant 3. What's my reference angle for 225 degrees? Well, that's going to be in the third quadrant, so I'm doing 225 degrees minus 180. 225 degrees minus 180, so I'm really looking at the cosine of 45 degrees, and I know it's in quadrant 3, so it's going to be negative. Alright, and these are the values you have to know like the back of your hand, so I'm looking at negative square root 2 over 2. So I've got 1 plus, I found that off to the side, that's going to be negative square root 2 over 2, all over 2. Alright. And we're not going to leave it looking like this. This looks pretty messy. So the easiest thing to do is when you've got a complex fraction or a fraction within a fraction, just go ahead and multiply every term by the common denominator, which in this case is going to be 2. 2 is my only denominator, so I'm going to multiply all 3 of these terms by 2. So I've got 2, 1 times 2 is 2, minus, because there's my minus sign. When I multiply this by 2, let me write it out. Okay. Multiply that by 2, multiply that by 2, multiply that by 2. Alright, so those 2's are going to cancel out. I'm going to be left with the square root of 2 all over 2 times 2, which is 4. Alright, and this actually turns out to be a good thing because I've got the square root of all this up here and the square root of 4 on the bottom. Well, I know the square root of 4 is 2. And then nothing up there simplifies, so just leave that. And I know it looks crazy, but that's my answer.